Good morning, everyone. I'm Eric Burns, President and CEO of BIRNS Inc. And with me here today is our Technical Sales Manager, Bruce Meredith. Welcome to our webinar. If you have any questions at any time, please type them into the Q&A section so we can address them at the end. This webinar is about a new interconnect breakthrough technology developed here at BIRNS with capabilities that were previously almost unimaginable. Subsea data transfer rates of more than 9 gigabits per second over copper lines for deep submergence cable assemblies rated to 6,000 meters. Before I turn this over to Bruce, let me say a few quick words about us and our company. We opened our doors in 1954, making underwater camera housings for the Polaris missile testing project, and soon after began making subsea lighting systems for the US Navy. Our lights were used in high-profile projects for years, from Sealab to major archaeological explorations. Eventually, we began making the connectors for our lights and subsequently responded to industry demand for connectors and cable assemblies. Our connector division quickly grew and is now the most significant division in our company. We evolved from developing simple 3-pin electrical connectors for marine lighting in the early days to helping shape the face of current connector technology. Today, we provide faster data transfer for better telemetry and communications and safer, more reliable power distribution in some of the most demanding environments on the planet, from under the polar ice to the deepest parts of the ocean. We are continuously working to improve our processes and products, and our quality and production certifications are part of our ongoing commitment to excellence. All BIRNS electrical and assembly technicians and inspection personnel are certified to J Standard 001 Class 3, which is the requirements for soldered assemblies, and also WHMA A620A Class 3, which is the requirements and acceptance for cable and wire harness assemblies. Our molding facility is one of the few in the US certified to develop and test outboard cable assemblies for US Navy submarines. Now at this point, I'll turn it over to Bruce.
Thanks, Eric. Optical fiber connectivity has long been the gold standard for high-speed data transmission. Fiber provides high performance, low insertion losses, and incredible data speed, and we've developed some highly advanced solutions in fiber optic connectors. However, the U.S. Bureau of Industry and Security has strict export regulations, EAR, on subsea optical connectors, which can impact some customers' ability to sell or resell their product, which use BIRNS optical connectors. This has put some limitations on connector selection in subsea vehicles, which might otherwise include fiber. On the other hand, electrical connectors are not impacted by these restrictions. So this presentation will explore the technical and performance specifications of BIRNS cable assemblies with this new capability, which provides true near 10 gigabit Ethernet data speeds in an electrical connector option instead of fiber. It will explore the range of options available in pin configurations and cabling, how our team developed and tested the program, and how true gigabit Ethernet data rates can support a range of demanding subsea applications. Many developers of subsea systems require high performance in a smaller package. That has been the case for at least the last decade. What is new is the ability to provide the kind of Ethernet data rate speed in subsea connectors that has heretofore been only found in wired connections in enterprise computer systems. Until recently, data transfer rates for commercially available underwater connectors had been limited to so-called Ethernet speeds, that is around 1 gigabit per second. What's more, it wasn't clear if testing of those connectors had actually been done, as objective quality evidence in the form of test data was not available. Against this backdrop, we were asked if BIRNS could develop a connectivity solution providing 10 gigabits per second for a customer's new deep submergence AUV. This performance represented a full order of magnitude improvement over all existing connector products. The customer needed an extremely fast data transfer rate to allow for real-time data streaming and download capability, a fast dockside data dump. Our team focused on 4 elements during the development: the connector, the cable, the termination, and the overmolding. For the connector, we selected the BIRNS Millennium 3M16 proof of concept. In addition to 4 16-gauge contacts for power, seen in the center, this connector has 12 22-gauge data contacts, which were appropriately grouped for shielded twisted pairs. Next, the team focused on developing a new high-speed cable, the 52A278 power and high-speed signal cable. This cable needed to resist crosstalk, both near end and far end, as well as alien crosstalk, and resist potential electromagnetic interference from the power lines. It also needed a 7,000 meter depth rating. We chose 4 300-volt capable balanced twisted shielded pairs for the signal lines, individually screened to protect against EMI, and 5 15-gauge 600-volt conductors for power. These were bundled together in a central water block core with a triple layer, 100% overall coverage screen, a 1mm TPE core jacket, and a thick outer layer jacket of polyurethane. Connectivity this advanced required a unique approach to cabling, and the result was a highly complex cable which included construction to Cat 8.2 requirements and nonetheless had an external diameter of only 3/4 of an inch and a bend radius of 7.5 inches. The BIRNS team developed exclusive new proprietary termination protocols, Signal Group Method 3, to further reduce loss and increase bandwidth for this unique cabling. The termination between the cable to the connector was critical. Because the twisted shield pairs were balanced, their individual twists needed to be maintained at the same twist rates right up to the connector. Their individual shields were also continued right up to the connector, and their drain wires were terminated to connector pins in order to drain away any spurious EMI noise caused by the power connectors. Finally, the cable's overall screening, which consisted of 3 separate layers, was terminated to the connector shell in a 360-degree format for a completely effective screen. As mentioned earlier in this presentation, all relevant BIRNS technicians are certified to J Standard 001 Class 3 and WHMA A620 Class 3, and we have two full-time authorized certifying instructors on staff. The final stage of development related to the cable overmolding, or potting. The overmold must not only provide a secure waterproof protection for the termination, connector, and cable, it also needs to suitably retain the complex termination and shielding in position. To this end, BIRNS also designed and developed new custom mold tooling specifically for this project. The project's results were so successful that we expanded the tool design range to include all of the BIRNS Millennium connectors. These new overmold designs provided repeatability and secure polyurethane cable sealing and are our next-gen series, which are now available through our catalog. BIRNS has a NAVC Pro 20 certified overmolding facility, one of the few approved by the U.S. Navy for the manufacture of outboard cables for naval submarines. Our team has been creating custom solutions for the world's most demanding environments since 1954 and invested heavily in advanced technology and protocols for its cable assembly overmolding. The first cable assembly we developed was for the customer's AUV. It was a double-ended assembly with a BIRNS Millennium 3M16 cable plug, or CP, on each end. We installed the test cable into the pressure chamber and connected it to 2 mating 3M16 FR receptacles. The receptacles were terminated with data leads connected to a high-speed computer workstation, which was configured as both server and client utilizing dual Synology 10 gigabit Ethernet network interface cards. Our team set up a customized server-client relationship through the test cable, utilizing the software iPerf3 to send packets of various sizes and record the transmission rates. The packet size and transit times were recorded in a log file. The data transfer rates were scheduled to be tested over the course of the entire test, from 0 PSI to full pressure and back again to 0. The testing of the data transfer rates under pressure was conducted by connecting the cable assembly to flange receptacles mounted inside our 15,000 PSI hydrostatic test chamber. Here, you can see the technician loading the assembly into the test chamber. After the chamber was closed and secure, the data transfer rates were tested and recorded for 1 minute at 0 pressure, and then as test pressure was steadily increased at every 1,000 PSI increment to the full 8,700 PSI hold pressure. The unit was then held at 8,700 PSI for 1 hour, while data transfer rates were tested continually. At the end of the 1 hour hold, the pressure was reduced to atmospheric pressure, and a final 1 minute transfer test rate was conducted. While at 8,700 PSI for the 1 hour hold, we were able to meet the following transfer rates. Once the 1 hour peak pressure hold and data transfer test was complete, the pressure was reduced to atmospheric or 0 bar, and a final 1 minute transfer test rate was conducted. We developed new protocols and hardware for this testing, and the data is sent and received from the same computer, and then packet size and transit times are recorded in a log file. While still submerged at 0 bar, the assembly then passed IR testing at 500 volts with a minimum resistance threshold of 300 mega ohms. This graph denotes the summary test results of the data transfer at increasing test pressures. The plot shows that overall, the data transfer rate holds at 9.4 plus or minus 0.1 gigabits per second throughout the pressure rates tested. As you can see, the blue line denotes that the test pressure was held steady, and the data transfer axis, you can see that the lowest glitch was a brief 8.5 gigabits per second. We have since expanded the options with Ethernet capability to include several other configurations. For Ethernet only, our BIRNS Millennium 3G10 with 10 number 22 gauge contacts, and for Ethernet and power capability, the BIRNS Millennium 3M13 with 5 16 gauge conductors and 8 22s, the BIRNS 3M16 size having already been discussed, and finally, the 3017 with 8 16 gauge conductors and 9 22s. Now back to you, Eric.
Thanks, Bruce. Nearly 10 gigabits per second data rates are in demand for a wide range of subsea applications. These can include such things as high-definition video streaming and monitoring, sonar digital downloads, defense reconnaissance and mapping applications, acoustic Doppler current profilers, LiDAR, which is light detection and ranging, seafloor imaging, and broad area surveying and inspection. The thing is that all such systems can necessitate enormous bandwidth and data delivery rates, and often require quick post-mission access to huge amounts of payload and vehicle management data. We have exhaustively tested our new cable assembly technology, and we strongly believe that its performance actually far exceeds 10 gigabits per second. However, existing computer technology currently limits accurate testing to around 9.4 gigabits per second. The limitation is primarily due to the fact that when managing ultra-high data rates, copper-based network interface controllers emit too much heat. Even high-end multi-queue network interface cards with TCP offload engines can be limiting. So enterprise data centers and consumer-level high-speed networks all use fiber optic lines. So interface card manufacturers have little reason or impetus to develop faster copper-based units. Nonetheless, we are thrilled to be leading the industry with these new and proven data transfer speeds. We recently performed additional testing of a system with an overall circuit length of 20 meters, about 65 feet, with 5 BIRNS connector interchanges in the line. And we measured a consistent 9.48 gigabit per second data transfer rate throughout the entire circuit, which strongly suggests that the actual rate is far higher. We are continually expanding our in-house test capabilities, and we look forward to seeing what we can accomplish and demonstrate in the near future. Here's how to reach us. And here's our specific contact information for Bruce and myself. At this point, we have a few minutes. We'd be happy to answer any questions. So let's take a look to see if there are questions in the Q&A section. We've got a question. Do you know what the per conductor pair data rate was through the test cable assembly? And was it about 25% of the overall bandwidth per pair? Personally, I don't have that information, but we can look into it and get it back to you. We'll take a note of that question. I want to also say that I want to remind you, if you've got questions, this is a great time to put them in the Q&A. The second question that came up is, have any RF test parameters been measured for the individual conductor pairs? There too, I'm not sure about the RF test results, so we'll need to look at that, and we'll get back to you with that question offline. Customers, regularly ask us if we can make cable assemblies using their customer-furnished cable stock, and the answer is absolutely yes. If you are interested, we will need to know some technical details about your cable, but absolutely we do that. We're also asked what cables we keep in stock. And the cables that we keep in stock are shown in the BIRNS Millennium Interconnect brochure. If this is available on our website and the BIRNS Millennium webpage, if you don't have that, we'd be happy to send you a direct link. Just please let us know after the webinar. We'll send you a direct link. We have another question. Is the characteristic impedance 100 ohms? And if the question is related to the twisted shielded pairs inside the cable, the answer is yes. The characteristic impedance is 100 ohms of those twisted shielded pairs. And another question, what is the longest cable assembly data rate tested under pressure so far? So far, the longest tested under pressure was pretty short. It was like 1 meter long, approximately. As we said in the webinar, we've tested up to 20 meters, but that has not been done yet under pressure.
We also get asked questions as, can we test electrical, optical, RF testing concurrent with hydrostatic pressure testing? And the answer is absolutely we can. We can also test at extremes of temperature down to about 0 degrees Celsius. If you have a specific requirement, send us what your profile is, and we'll certainly take a look at it and get back to you. I'm going to expand a little bit upon the data testing also. Perhaps with new interest from the industry, the demand for higher speed test rates will help push chip manufacturers like Intel, Qualcomm, Realtek, and others develop efficient cooling solutions for copper-based network interface cards and non-data center applications.
Looks like we also have a question posed in the chat. Do you know of any electrical Ethernet switches at 10 gigabit per second or 10 gig that could be used in AUV? And I think you said this was a problem due to heat. And yeah, so far, to be honest, we've only been looking for network interface controllers that could be used in a topside computer so that we could integrate it into our test bed. So we haven't specifically looked for any that could be used in an AUV. The best we could find, the best copper-based units we could find are rated to 10 gigabit per second, but their actual performance is a little bit lower as we saw during our tests. Those are Synology. If you're interested, we can be happy to send you the details of those offline. It's a great question.
We've also got a question, what is your shielding coverage for right angle overmolded connectors? It remains the same as the straight. We continue the shielding all the way up through the cable, through the overmolding, all the way up to the CP. And
to continue on that, the overall shield, that means the outside screen, we actually maintain it in a 360-degree shielding directly connected to the CP shell. Oh, and before I forget, please complete, we'll have a short survey after the webinar. Yeah, please do respond to that. Your feedback, good or bad, it helps us continually improve. And of course, please, everybody, feel free to contact Bruce and myself directly at any point. We're happy to answer any specifics. We do have a few more questions for Q&A in case we have additional questions. Well, if there are no more questions, and again, please feel free to contact us directly at any time. On behalf of everyone here at BIRNS, I'd like to thank you all for attending today. We sincerely appreciate your time and your support. Thank you very much.
Thank you very much.
Well, it looks like we got, sorry, looks like we got a couple of last minute questions. I'll just hurry up before everybody leaves. Is there stocking availability? Yes, there is. We do stock connectors, we stock cables. We don't actually stock cable assembly, but we're happy to do that as well. So please talk to us directly. And have you tested motor controller signals through these connectors? No. So far, the only testing that we have done has been strictly related to signal. So, and just data transfer signal, just pretty much raw data packets. But we're happy to do that. Let us know what your requirements might be. We're happy to take it up. What cable jacket material was used in your terminations? So I believe the question relates to the material of the jacket, of the cable jacket, and that is polyurethane. It's, I think it's 85 Shore polyurethane. And if the question relates to, since it's used in your terminations, if it relates to the electrical terminations themselves, we use a commonly commercially available heat shrink tubing, which I believe is polyolefin.
Did your pressure testing include fiber? We have tested some of our fiber solutions down to 14,000 PSI successfully. So the answer is yes. It was not part of this particular test, but we have tested our fiber solutions to both extremes of cold and extremes of pressure.
Looks like we have another question. Can you email us a brochure or catalog? Absolutely. Again, it is actually available on our Millennium webpage, but we'll be glad to send you and anybody else who's interested a direct link for the download, as well as a reference list. Typically, we maintain some confidentiality regarding our client list. We can provide some kind of general names if that's of interest. So here we go. Another one. Have you pressure tested terminations to high density polyethylene jacketed cable? And I'm not sure. We have done terminations to high density polyethylene or PE jacketed cable, but I don't know if we've actually pressure tested them. That's something we would need to check into and get back to you. It's a great question. And looks like we've got a request. Bruce, I'm going to turn this one over to you. Can you go back a couple of slides to the series connection one and how many connections? I believe that there were 5 connections in series, you might say. So Bruce, if you can please take us back there a couple. There's 1, 2, 3, 4, 5. It looks like there are 5 BIRNS interface connections here. And I believe all of them are 3M16. We've got a question. What is your typical delivery on these products? It's hard to give a straight answer because the BIRNS Millennium series is pretty wide. But if you're referring to standard connectors and standard cable stock, then the typical delivery is usually between 8 and 12 weeks. We've got some great questions here. Please, everybody, keep them coming. More questions. It's a great time for it. We have a question here. Do you believe that your current hardware will be able to deliver an even higher rate than 10 gigabits per second? That's a great question. And the answer is yes. We believe that presently we are actually getting significantly higher than 10 gigabits per second right now. The problem is that we don't have any way to accurately test or to provide objective quality evidence that we actually do. We believe that we do because here we've taken 5 connections, put them in series, and we still get the same rate. So once we have a way to reliably test for higher data rate, then yes, we believe we'll be able to provide objective quality evidence that they do. We have another question here. Do you provide support for field terminations? Yes, we do. It's not something that we do very often, and particularly in today's pandemic world, it's been a little challenging. But yes, we do that. We'll be happy to speak with you about that offline. That's a great question. In fact, it reminds me that we actually had a large contract with a portion of the U.S. Navy to go to their site and perform terminations on site. So we were all geared up to do that. Unfortunately, then the pandemic shutdown occurred, so we had to change plans. But so back to the question, yes, we are happy to provide support for field terminations. And just in case I didn't answer that clearly, back to the field terminations, it's not just terminations, but actually overmolding. Overmolding is sealing or potting of connectors. We do that remotely as well. Another question, do you provide training for terminating your connectors? It's not something that we have done in the past, but we're very happy to do it. So again, contact us if you're interested. Training of that type could be performed here on site or at the customer site.
Christopher, we have some documentation which gives some termination protocols for our BIRNS kits, which we keep in stock. And I'll go ahead and send that to you, at least as a starting point of a discussion. And anybody else that would like that information, certainly you can go ahead and contact me.
That's a great point, Bruce, but I want to point out to everybody that our instructions do assume some familiarity with standard termination protocols. Okay, so it looks like we might be coming to the end of the questions. Bruce and I, of course, are always available to anyone. Just contact us directly. I don't want to cut this short, but if there are no questions, or neither do I want to have everybody hang on. Again, I'd like to thank everyone for coming today. And again, please remember, complete the survey directly after this webinar. We really want your feedback and we want to know how we can improve. So again, thank you, everybody. Hope you have a wonderful day and thank you for attending.
Thanks, everybody.